Now let us learn how to find the horizontal asymptote. How to find the horizontal asymptote. So let us learn how to find the horizontal asymptote. Let's say you have a rational function y equal to fx divided by gx. There are three cases. What are the three cases? What are the three cases, guys? What are the three cases? The first case is that the degree of fx, is lesser than the degree of gx. The degree of fx is lesser than the degree of gx. What is an example? The example is x minus 3 upon x square minus 4x. If you see, the degree in the numerator is 1, the degree in the denominator is 2. So the degree of numerator is lesser than the degree of denominator. First case. Second case, the degree of fx is same as the degree of gx. Okay, what is an example? The example is x minus 3 divided by 2x plus 4. Okay, if you see, both in numerator and denominator, the degree is 1. Both in numerator and denominator, the degree is 1. If you see the third one, the third possibility is that the degree of fx is greater than the degree of gx. What is an example? The example is x square minus 4x divided by x minus 3. X square minus 4x divided by x minus 3. So these are the three possibilities in a rational function. These are the three possibilities in the rational function. Now, I'll just make, these are the three possibilities. In the first possibility, if the degree of fx is lesser than the degree of gx, your horizontal asymptote is simply y equal to 0, which is x-axis, which is your x-axis. Okay, if the degree of fx, if the degree of numerator is lesser than the degree of denominator, your horizontal asymptote will be x-axis. Your horizontal asymptote will be x-axis. If you want to check, you can check. The example is x minus 3 upon x square minus 4x. The example is x minus 3 divided by x square minus 4x. Okay, so this is your, if you see carefully, the x-axis, if you observe the x-axis, the curve is trying to touch the x-axis, or you can say that x-axis is trying to touch the curve, but they never touches. I'm going towards the right. Mark the x-axis. Now you will say that at x equal to 140 they have touched, but if I zoom it, observe 140, it hasn't touched the x-axis. So always remember, whenever the degree of numerator is lesser than the degree of denominator, the horizontal asymptote is your x-axis. The second possibility, what is the second possibility? If the degree of fx is equal to degree of gx, then the horizontal asymptote will be ratio of coefficients with highest degree. What I mean to say is, you see that the degree is 1, right? So what is the coefficient? The coefficient is 1 here. Okay, in the denominator also, if you see, the degree is 1. What is the coefficient? The coefficient is 2. So what will be the horizontal asymptote? The horizontal asymptote will be simply y equal to 1 by 2. The horizontal asymptote here will be simply y equal to 1 by 2. I can give you another example. Let's say if your function is y equal to minus 2x square plus 4x minus 3 divided by 6x square plus 3x minus 4. Let's say this is your rational function. What is the degree? The degree is 2. The highest power is 2. So you check the coefficients. What are the coefficients? The coefficients are minus 2 and 6. Minus 2 and 6. So what will be the horizontal asymptote? The horizontal asymptote over here will be y equal to minus 2 by 6. So y equal to negative 1 by 3. Y equal to negative 1 by 3. Y equal to negative 1 by 3. Okay. So this is how you find the horizontal asymptote. This was your second case. Now the third case. If the degree of fx is greater than the degree of gx, if the degree of fx is greater than the degree of gx, in this case, you do not get any horizontal asymptote. You do not get horizontal asymptote. What do you get? You get oblique asymptote. You get oblique asymptote.